Examples on when you need some additional capacity. A good example is our discussion of this morning. If you want to enable deduplication, compression, encryption, or these kind of features, you're going to need to evacuate the data. Okay? The evacuation of the data from one host to the remaining hosts require additional capacity to be available. Okay, that's an example about the need of having available capacity, not for the actually running VMs, but for some kind of operations. We also need this extra capacity to be available when, for instance, you are moving from one RAID to another. You can simply change the policy of a VM. This is something that you can do live. Okay, there is no need for powering off the VM whatsoever. I will demonstrate that later. Okay, once I add the fourth node. I heard a beep. Maybe a question in the chat. Okay, I come back. So if you want, you can change the policy live without the need of powering off the VM or whatsoever. So you can simply right-click, change the policy, and move from RAID 5 to RAID 1. And here is how it works. So you can have a VM using RAID 5. So the VM in this case will have component, 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 component. That's 150 gigabyte for an object of 100. Okay? If you move to RAID 1 with an FTT of 1, it's going to become component, component witness. That's 200. How will vSAN manage this? vSAN will keep the components of the VM in their RAID 5 architecture, and at the same time it's going to start building the new components using RAID 1. So during this period of time, the VM will consume, this is just about, this is for, by looking at the VMDK only, okay? The disk object only. We're not talking about the swap and everything else. So for the disk object only, the VM will consume 333, or sorry, it's I did a mistake there. RAID 5 is 133, not 150. That's RAID 6. So during this period of time, the VM will consume 333 gigabyte of capacity. So that's why you need to have some capacity available for this kind of operations. Before the introduction of the automated calculation of the reserved or the required capacity that needs to be reserved, there used to be a manual way of doing that. It was called slack space. So VMware recommended back in the days to vSAN customers to have between 25 to 30% of capacity available for this kind of operations. Okay. Now it's automatically calculated. You just need to enable the feature. The feature can be enabled at two levels. So you have two options. As you can see here, you have operations reserve and host rebuild reserve. Two options. The second one, the host rebuild reserve, cannot be enabled without enabling the first one. Okay? You need to enable the first one, then the second one. This is not hard limits in vSAN. I will explain why in a moment. But let's look first at what these two reserved capacities are used for. The first one, operations reserve, is actually used for this kind of operations. When you change the policy, when you migrate the data, when you just need to make some changes that require temporary placing the data somewhere, that's what operations reserve is used for. Host rebuild reserve is actually reserving the equivalent of the capacity of one host in case that host goes down or removed or used for something else. For example, when the data is completely evacuated, you can have enough capacity available to move the entire data without having any issues. Reserving the equivalent of the capacity of one host. And for example, if you have an environment with 4 hosts, let's make things a little bit simple. You have 4 hosts, which are exactly the same in terms of the hardware configuration. The total capacity of your cluster is 100 terabytes. This means that each host is participating with 25 terabytes. Okay? If you enable the 2 features, host reserve will require to reserve 25 terabytes of the capacity, because that's the equivalent of what each one of the hosts is actually providing as a capacity to the cluster. Okay. Now, if you see this example, reserving 25 means that we reserve 25%. This is just for the host rebuild. Now, for the operations, we need to add something like 5%. That's a total of 30%. For this kind of environment, it's valid. Okay? This is the method that we used to use before. But if you apply the same thing for larger clusters, the results will simply reserve a lot of capacity, which is not really ideal. That's why they introduced this automated way of calculating how much is needed based on the actual available resources. The more resources you have, the less it's going to be reserved. Look at the 2 examples we have here. The first cluster is relatively a small one. We only have 4 nodes with a total capacity of 174.62 terabytes. Okay, we enabled both features, and you can see the results. The total capacity reserved represents 28.25% of the overall capacity. This is a 4 nodes cluster, so 25% from this is for host rebuild. Okay, 3.25% is for operations. Okay, if we look at the numbers, the host rebuild reserved 43.66 terabytes of the capacity. That's the equivalent of the capacity of one host. So you can take just this number here. The total capacity divided by 4, you're going to have something like this. Operations reserve reserved 5.68 terabytes, and this is the total capacity reserved. Out of 174, we have 49, almost 50. That's a lot, because it's a small cluster. If we look at the second example, here we have 24 nodes and a huge capacity of 670 terabytes of storage. Look at the overall reserved capacity. It represents only 7.86, almost 28 terabytes for host rebuild, and 24.73 for operations reserved. So the total reserved capacity is 52.68. That represents only 7.86. This is due to the fact that we have a lot of resources available. So we can set some capacity aside in case of host failure or if it's needed for different operations. So having a large cluster isn't really a requirement only if you need those resources, but also if you want to have enough resources in case of failures or different operations that you are applying to your environment. Now, as you can clearly see here, when you reserve the capacity, as you can see, this is the operations, okay? And this represents the host rebuild. In other terms, from here to here, this is the available capacity that you can use. Okay, all this. This is the available capacity. Now, what would happen if you consume all this capacity? So first of all, as you can clearly see, you have the possibility to configure some alerts. So here at 70%, there is a warning. At 100%, critical error. So you're going to be notified when you reach 70% of the available capacity. If you consumed 100% of the available capacity, if you try to deploy new VMs, you will be prevented from doing that. The vSAN will say, no, I don't have any more capacity. But for the VMs already deployed, they can definitely start consuming the available or the reserved capacity. That's why I told you in the beginning that this is not a hard limit. Okay? So how do we enable this feature? There are different ways of doing it. You can again, so you can go to services, or you can select the cluster, then monitor, okay? Capacity, click on capacity usage, and from here you have reservations and alerts. Or you can simply go to vSAN services, where you pretty much have settings for everything. vSAN services, configure, you have reservations and alerts, and you click on edit. From here, you can not only configure or enable the feature, operations reserve and host rebuild reserve, but you can also customize the alerts. For example, 80% for warning and error at 100%. Or you can get a warning at maybe 70% and 90% you get an error. It's up to you. The most important is to get notified before the available capacity is actually consumed. Some requirements. This feature cannot be enabled in clusters with less than 4 hosts. This cannot be enabled in stretched clusters and cannot be enabled in clusters with fault domains and nested fault domains. So these are concepts. So nested fault domains is not discussed here. This is a concept specific to the 2 nodes type of clusters. And fault domains is something that we will cover later. Okay, any questions about reservations and alerts? No? Okay, I hope that everything is clear, because you guys are not asking too much questions. Okay, all right. Okay, perfect. All right, so next we'll talk about disk balance. This is something I already mentioned yesterday. So disk balance means that in a distributed environment like vSAN, we have plenty of disks. So vSAN will try to use the disks equally. So we're going to try to distribute the load across all the disks. The objective here is to not have one disk being used more than the others. There may be situations where this can happen. For instance, you have a cluster with 6 nodes. Okay, everything is well balanced. Next day, you simply added 2 additional nodes. The nodes you just added will come with additional storage. So if we look at the storage usage, we're going to see 0 usage in the 2 nodes, and all the other disks are full of data. So this is an imbalanced environment. Okay, in this case, if you set this option to automatic, vSAN will not ask you. It will automatically start migrating the data from the existing disks to the new hosts without asking you. There is no option to manually trigger disk rebalance. You either set this to disabled, which is the default value, or you can manually enable it and set it to automatic and let vSAN do that for you. vSAN is intelligent enough to know the exact moment when moving the data is possible, but by looking at bandwidth usage and resource usage in the environment. You just need to be careful when making some changes to your environment. For instance, the example I gave you before, you have a 6-node cluster, you just decided to add 2 new nodes. And you just forgot to put the 2 nodes in maintenance mode. So they are available immediately to the environment. The environment is quite busy, running plenty of workloads. vSAN will immediately start moving the data, and that may hit the performance. Ideally, you should keep the 2 nodes in maintenance mode until the resource usage is very low. Then you can exit the maintenance mode and make those hosts available for usage. This will help to avoid any stress, putting the environment under stress by moving the data through the vSAN network. The disk rebalance threshold is 30%. So vSAN will look at the delta of disk usage between different disks and see if one disk is being used at more than 30% compared to the others. If it's the case, you get a notification using one of the tests available at Skyline Health that we discussed yesterday, which is this one, vSAN disk balance. Okay. Here is an example. It's going to tell you exactly which disk needs rebalance and how much data needs to be moved from that disk off to other disks. The feature can be enabled from the advanced settings. Again, you need to select the cluster. You need to go to the configure tab. From there, vSAN services, and you're going to find the list of advanced settings. That's something you can find from here. Select the cluster, configure, then vSAN services, and you have some advanced settings accessible from here. So you can pretty much configure anything you can think of from here. You have SCSI, file services, everything can be configured from here. You have the advanced options. Okay. From the list of advanced options, you can enable automatic rebalance. Okay, default value is 30%. It's better to keep 30%. If you decrease this value to like 15 or less, you may experience a lot of data movement. If you increase this value, it's not good for correctly using resources in your environment. Keep in mind that this algorithm and the previous one for capacity reservation both work well when the environment is well balanced. And I mean by well balanced, when you have homogeneous environment and the nodes are exactly the same, you can just imagine how hard it is for vSAN to balance disk usage when you have a node that is participating with 30 terabyte, another one with 25, another one with 15. That's almost impossible to have exact numbers. That's why it's always good to have well-balanced environments and where all the nodes are exactly the same in terms of hardware configuration. So you can see here some of the advanced settings. Needless to say that in VxRail, we apply the best possible settings for you as a customer. So you have the object repair timer. I'm just going to take this opportunity to talk briefly about these settings. Not all of them will be covered in this class, of course, but I think it's worth spending some time talking about these settings. So you have the object repair timer, 60 minutes. Keep this number in mind. We'll get back to it later on when we talk about troubleshooting. Not really troubleshooting, but how vSAN will handle failures. I will give you a few examples so you can actually have an idea about what you should expect in your environment if you are experiencing any failures. You have the site read locality. This is important to understand. Yesterday, I think I talked about this yesterday when we discussed reads and writes in vSAN. So if you have 4 nodes, for example, we have component, witness, in the case of read 1. Okay, so for read, in order to improve the performance, 50% will be served from here and 50% will be served from here. Okay, in a stretched cluster, and some mentioned that he's managing a stretched cluster. In a stretched cluster, you basically have nodes placed into 2 different sites, geographically separated sites. And you're going to have copies across 2 sites. The site read locality is a feature specific to stretched clusters, okay, that will basically prevent reading from both sides at the same time for performance reasons. Okay, so we were talking about the advanced options. So the first one is really about it is specific to stretched clusters. The second option, as you can see, it's enabled by default. Thin swap. So thin swap means that the swap object will always be thin provisioned, regardless of what's actually specified in the storage policy you are using for this specific object or for the VM. So this will guarantee that the swap object will not consume storage from vSAN. Because why would you need to thick provision the swap? It's not really needed. Unless you are running out of memory, if there are some business critical VMs that you would like to, you would like to give them or reserve some capacity for them for the swap in case of memory not being available, so they don't get impacted due to that. You can maybe specify that you can create a policy specifically for these VMs with thick provisioning. I'm going to talk about that a little bit more later when we start the discussion about storage policies and more specifically the advanced settings. Next, we have large cluster support. This is definitely enabled in VxRail. By default, the vSAN standard cluster is limited to 32. If this is not enabled, it cannot reach the 64 number of nodes. If you do this, the moment you reach 32 nodes, that will require rebooting all the nodes. So, in order to avoid doing that, we just enable it from day 1.